This is a graphical example of taking the derivative of the sine function. So we start with the graph f of x equals the sine of x. Now, the easiest way to graphically estimate a derivative of a function is to look at where the function has a maximum or a minimum, because at that point we know the slope of the tangent will be 0. So if I look here, I know that my tangent line will have a slope of 0. If I look at this point here, I know my tangent line will have a slope of 0. Slope of 0. And over here, a slope of 0. So I'm going to start initially by graphing on the graph below the derivative at those four x locations. So at this x location here, which is negative 3 pi over 2, the derivative I know will be 0. At pi over 2, the derivative will be 0. Negative pi over 2. At positive pi over 2, the derivative will be 0. And at 3 pi over 2, the derivative also will be 0. So we know at least those four exact values from negative 2 pi to positive 2 pi derivative of sine. Now, the other ones we're going to use an estimating technique. We can clearly see, let's look at some of these intervals in here, that between this point here and this point here, that my derivative is negative. My function is decreasing. So all the way between negative 3 pi over 2 and negative pi over 2, I expect my derivative to be negative. Now, it'll appear like at this point here that my derivative is the most negative. With a very good graph and a ruler, we could properly estimate this slope of that tangent line at that, going through that point, its derivative to be approximately negative 1. When I move to x equals 0, I notice at this point here that I appear that my graph is at its steepest. With proper graph techniques and a ruler, we could estimate the slope at that point of the tangent to be about positive 1. And again, over here, the slope of the tangent would be estimated roughly at negative 1. At this point here, my slope would be about positive 1. Over here, my slope is going to be about positive 1. Now, if we were to connect these dots with a smooth curve, we would begin to recognize that this should be a familiar shape. Not very good. Cosine. Yes, this is the cosine. Which then I will theorize that the derivative, well, let's write it this way, that the derivative of the sine function is in fact the cosine function.